Physical science. It's class time. And as we do on this Thursday, we are going to start with our study guide. So please get your study guide out, get your textbook out, pause me so you can go grab those and then come back. Okay, so I've debated on whether or not to just take pictures or have you grade them like we do in class. And I'm just going to stick with what we've been doing. Even though it's harder, it takes more work on my end, more work on your end. It is through hard work that we achieve great things. And I want you to stay in the practice of learning from your own work and not just sending you an exact copy of all the answers. So here they are. Are we ready? Number 1, the 4 fundamental forces: gravitational force, weak force, strong force, and the electromagnetic force. Now, the electromagnetic force and the weak force are really 2 different facets of the same force. So if you told me there are only 3, you would be also right, but we're going to stick with those 4. The weakest force is the gravitational force. That's number 2. And the strongest one is the strong force. That one should be easy. Okay, question 3. The 3 principles are: all objects with mass are attracted to one another by the gravitational force. Number 2, the gravitational force between 2 masses is directly proportional to the mass of each object. So as the mass goes up, the attraction goes up just as much. And the gravitational force between 2 masses is inversely proportional to the square of the distance between those 2 objects. So you're taking that distance, you're squaring it, and it being inversely proportional means it's in a fraction. It's underneath. You'd be dividing by that number. Okay, number 4, 4 times larger. Number 5, 16 times smaller. Number 6, 90 times larger. Number 7, the equal and opposite force is the gravitational force that Venus exerts on the sun. Number 8, centripetal force is required for circular motion. Number 9, circular motion requires 3 things: centripetal force. The larger the centripetal force, the faster an object travels in a circle. And at a given speed, the larger centripetal force, the smaller the circle. We are halfway. Number 10. A, more force. B, less force. Number 11. It's a myth. There is no such force. Number 12. I'm going to show you the picture. There we go. See that guy right there. Boom. Okay. 13, we've got inner planets: Mercury, Venus, Earth, and Mars. And then we have our outer planets. Also, there are 4 of them: Jupiter, Saturn, Uranus, and Neptune. Number 14 is all of those together. So just read them again. 15, Saturn, Uranus, Jupiter, and Neptune. 16, most of the asteroids are between Mars and Jupiter. 17, perturbations in its orbit. 18, these are the parts of a comet. It's got a nucleus, a coma, and a tail. The nucleus is always present. Now, I always go back and forth if it's comma or coma. You go with whatever works for you. 19, when the comet is closest to the sun or when it's close to the sun. 20, the comet orbits in an elliptical orbit. 21, the Kuiper belt. 22, gravity is caused by the fact that objects with mass bend space and time. And 23, according to the graviton theory, gravity is caused by the exchange of particles called gravitons, which is when we threw those tennis balls back and forth. That's our study guide. Okay, check. Next is we're going to do a lab. And if you have this material, that's awesome. If you don't, my hope is to do a video of my kids doing this experiment, and then you can use their data to write it up. But all you need is a balloon and some string and some tape. So I'm going to tell you what to do. And then if at some point you can do this activity this week, send me a picture of you doing it, or just do the lab write-up and I'll believe you. Okay, so you are going to blow your balloon up, tie the string to the end, and you're going to want it to probably be 4, 5, 6 feet. I've just used sewing thread in the past, so really, really thin thread. And then you're going to make a little circle on the end of your string with a tack, and either tack it to your ceiling or tape it to your ceiling, whatever works best for your parents. You could do it in a doorway, but the balloon's gonna move quite a bit. And so maybe a bigger doorway. You couldn't do it outside because of the wind. So you really want static electricity to be the main thing that's affecting that balloon. Now, if you have 2 balloons, that's what's the most ideal. So now you're gonna blow your second balloon up, tie it, because you're amazing, and you're gonna rub that balloon, and you're gonna bring it close to the balloon that's hanging on a string, and you're gonna see what happens. This is mostly just a fun, experimental playtime is really what it is. So what I would have you do in class is to figure out, does one side of the balloon react more? How close can you get before they respond? If you rub it your hand more often, does it work more? Does it respond to your hand? Does it respond to your hair? Does it respond to your clothes? And you're just testing things to see what's going to make this balloon on a string move. No set question on this one, other than what happens to the static electricity on a balloon. Charge the one that's hanging and charge the one in your head and see if they do something different. The goal is just to play and to see what happens with static electricity. That would be our class, and I summed it up in 7 minutes. So, I hope you're doing well. Please message me if you have questions specifically about those study guide questions, or if you want me to do some math problems. I am so happy to do that and send some examples. And your test opens, so send me your stuff. I want to see your work so I can put it in the grade book, and I'd love to see your evening of the arts data tables. That's your synthesized data that looks amazing. And I'll talk to you later.